Hello and welcome to the ESOcast. Capturing and recording the light from the heavens has always been a central aspect of astronomy. In this episode, we're going to delve into the history of the sensors that have been used to study the universe over the centuries. The very first astronomical detector was, of course, the unaided human eye. It wasn't until the early 17th century that we started to use a tool to help us see fainter and more distant stars, the telescope. One of the first astronomical uses of the telescope was by Galileo Galilei back in 1609. Amongst many other things, he discovered the 4 largest moons of Jupiter, which forever changed our view of our place in the universe. But in order to record what they saw through the telescope, Galileo and the astronomers that came after him had to make do with pen and paper. They had to draw what they saw. Around 230 years later, in the middle of the 19th century, this dependence on the human eye finally ended. Instead, astronomers started using photographic plates to detect the light from celestial objects. Now, these had several advantages. To begin with, photographic plates can be exposed for hours on end, allowing astronomers to detect much fainter objects than was possible by eye. And, for the first time, astronomers had a faithful image of the night sky instead of just a sketch. But, although a huge improvement over the eye, photographic plates were far from perfect, and so the quest for greater sensitivity continued. As technology progressed, eventually electronics entered the picture. Photomultiplier vacuum tubes became available in the 1930s. They convert an incoming photon into an electron, which is then repeatedly multiplied in order to generate an easily measurable electrical current. Now, photomultipliers had a sensitivity that was about 10 times greater than that of photographic plates, but they were cumbersome to use, being essentially just a single pixel camera. However, everything changed with the advent of digital imaging in the 1970s. Charged coupled devices, or CCDs, are extremely light-sensitive semiconductors. They consist of a thin layer of silicon divided into millions of tiny squares, each representing a picture element or pixel. Scientists and engineers at ESO have helped to push the boundaries of CCD sensitivity and size. Now, initially, CCDs were really small. Over time, they became larger, like this one, and today they can be as large as 9,000 by 9,000 pixels. That's 81 megapixels in total. And these huge CCDs can even be mosaicked together to produce cameras with more than 1 billion pixels. This is not the end of the road, of course. As the technology continues to develop, we can look forward to future detectors that will be even better at catching the faint drizzle of light from the cosmos. This is Dr. J, signing off for the ESOcast. Join us again next time for another cosmic adventure.